To solve this data sufficiency question, we'll consider each statement separately first and then together if needed. Before the statements, let's go ahead and define some variables so we can reference the slopes a little bit easier. Let's go ahead and call n sub k the slope of line k, and then we'll call m sub n the slope of line n. We need to determine whether mk, the slope of line k, is greater than the slope of line m, so mn. This is the relationship that we're looking to answer, a yes whether it's greater or a no whether it's not. And we're going to be using the information from the statements to determine this. So let's go ahead and let's take a look at statement 1 first. It's given that the y-intercept of line k is negative and the y-intercept of line n is positive. Knowing the y-intercept of a line does not tell us anything about its slope. So lines k and n can have any slope. If we don't know the slopes, we can't determine if mk is greater than mn. We still wouldn't know this relationship since we don't know anything about their slopes. So this statement alone is not sufficient. We can actually eliminate answer choice A and answer choice D, leaving us with B, C, or E as our final answer choices. Let's go ahead and take a look at statement 2 and see whether this statement alone will be sufficient. For this statement, it's given that lines K and N intersect at the point -2, 3. Lines containing this point can have any slope. If we think about an example, let's scroll down a little bit to draw a quick graph. Suppose we have a graph where lines K and N intersect at the points -2, 3. So say we're here. It would be -2 and 3. We could have a line go this way with a negative slope. We could have something that goes this way with a positive slope. We could even have a vertical line. So there's no way of telling what the actual slopes are if we don't know, if we only have one point where they intersect. So even though we know where they intersect, it still doesn't help us find the slope. So this statement alone is actually not sufficient. We can eliminate answer choice B. In addition to this, if we wanted to, we can actually pick concrete values for each of the slopes and compare. We would be able to find cases where mk would be bigger than mn and cases where it would not be true. It would be the other inequality. So let's go ahead and let's clear our board. And our last option, since we still don't know which answer choice we should pick, it's between C or E, we need to combine our statements. So let's go ahead and combine statement 1 and statement 2 and see if the information together will be sufficient enough to determine yes or no if this is true. We know that the lines intersect at the point -2, 3, and that the y-intercept of line K is negative, and the y-intercept of line N is positive. We can use the slope-intercept form to find an equation for each of the lines. So let's go ahead and let's do that, and then we'll compare their slopes. Let's start with line K. Using the slope or the point slope form to find an equation for the line, we have y minus y1, which is the point that it crosses through, so 3, equals mk times x minus x1, which our x1 is the line that the point that it crosses through, so minus -2 would give us plus 2. If we simplify this a little bit, isolating y, we end up with y equals mk times x plus 2mk plus 3. This right here, this 2mk plus 3, that is our y-intercept. So we want to keep that in mind because statement 1, when we're combining our two statements, tells us information about the y-intercepts. So mk would be our slope, and 2mk plus 3 is going to end up being our y-intercept for line k. So let's go ahead and let's do a similar thing for line n. So right below, we'll go ahead and work out the equation for the line for line m. It has the same point, so we have the same setup for point slope form in our equation. Y minus 3 equals m sub n times x plus 2. Now lining this up, we can isolate y. We end up with m sub n times x plus 2m sub n plus 3. Now again, this would be our y-intercept for line n. Now comparing the two y-intercepts, we know that for line k, the y-intercept is negative, and for line n, the y-intercept is positive. This means that our y-intercept for line k is going to be less than the y-intercept for line n. And let's go ahead and plug those in since we know the values that represent those. So the y-intercept of line k will be 2mk plus 3. And that's going to be less than 2mn plus 3. So we can simplify this inequality a little bit, just scrolling down to give us some more space. If we subtract 3 from both sides and divide out 2, dividing by an even number won't change the inequality, we'd be left with mk is less than mn. So we were after whether we could answer the question, is mk greater than mn? Let's fill that in. Is mk greater than mn? And in this case, it's actually the opposite. So we can answer that mk is not greater than mn. Now we were able to answer the question, if we scroll back up to read the question again, is the slope of line k greater than the slope of line n? The answer to the question here with both statements would be no. And even though the answer is no, we were able to find a definitive answer. So that means that they are sufficient together. So we can check those off, those are sufficient. And if we look at our answer choices, we can cross out answer choice E, and the correct answer choice would be answer choice C. Together, both statements are sufficient, but neither statement alone is sufficient.